The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered on the Howard College campus, agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are agricultural engineering, which is offered in Pietermaritzburg, and geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Centre showcases the college's scientific achievements and promotes the public understanding of science, engineering and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. The college has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centres within the college. The African Centre for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Centre for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Centre for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centres at the university, the Centre for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Centre for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of the transistor and the laser, and is currently being used to develop quantum computers and quantum cryptography. The college is committed to access and readdressing the disadvantages and inequities of the past. The highly successful Unite Engineering program and the Science Access Foundation and augmented programs offer alternative access to university, equipping students from disadvantaged backgrounds with the skills and knowledge to pursue their degrees of choice. Both these programs contribute significantly to advancing Black African scientists and engineers in South Africa. Staff and students contribute to a number of outreach and community initiatives that focus on social responsibility, sustainable development and upliftment of the wider community. The college also engages in activities involving the pursuit and understanding of science, engineering and technology through exhibitions, festivals and roadshows that target high school learners and the general public. The college has minimum entry requirements for its programs. These differ from degree to degree, but all require a national senior certificate and minimum performance levels in mathematics and either physical or life or agricultural sciences. For those who do not meet the minimum requirements, access programs are available. Additional information and brochures can be obtained from the contact information accompanying this video. The College of Agriculture, Engineering and Science is proud of its contribution to the university, the region and the country.
UKZN is one of the best. I definitely understand it's one of the best in South Africa. So for me, there was no other institute that I would have preferred other than UKZN.
We have the best facilities here in terms of laboratories, in terms of equipment, in terms of human resources, in terms of literature.
UKZN is one of the best universities in the country that teach agriculture or natural sciences.
What I think is good about this college is the level of international collaboration that we have. We have friendships with universities all over the world, which means that we're keeping up to a great international standard.
UKZN has got much more facilities and it's recommended worldwide to do your science studies here. Life begins here. Yes.
We continually strive to be academically excellent, innovative in research, and critically engaged with society. We invite you to join us or work with us to be part of this exciting team.
Everyone, can you see this piece of paper? So we're going to start with maths paper 1.
Hi, Rachel.
Yeah.
Rachel, could you share screen?
I've put my video on to write out the solutions.
You need to expand it through the share screen function, right? So share your video.
Need to be opened.
It's already open.
And I just want, we can open another.
Hi, Shan.
Yeah. Hello, morning. Then you got to share this one. You can hear me. Let's see participants.
Hi, Shan, we can hear you.
Okay.
Okay.
Good morning, everyone. Sincere apologies. I've been trying for the last half an hour to get connected. Now we are here. For this morning, we're going to start with number patterns, sequence, and series. We look at the document. I've listed numbers there, 1, 3, 5. There are 5 sets of numbers. The first one is 1, 3, 5. Well, it's a set of odd numbers. We all are familiar with odd numbers. And that is an arithmetic sequence. The next one is 2, 4, 8. Although they are even numbers, it is a geometric sequence because you got 2 times 2 is 4, 4 times 2 is 8, so the next number is 16, etc. The third set is 1, 1, 2, 3. Now that is a very special sequence. It's called a Fibonacci sequence. We start with 1. So to get to the next number, you also have 1. But it's easier to see that 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. That's the next number. And the succeeding number will be 5 plus 3 is 8. So that's a Fibonacci sequence. The next one is 2, 5, 10. Now, what is the rule? What's the pattern? What do you see there? Now, in an arithmetic sequence, example, the first one, you add to get to the next term. Example, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, etc. Second one, geometric, you multiply to get the next number in the sequence. Now here, if you go 2, 5, and 10, it is not arithmetic, it's not geometric, it's not Fibonacci. So if we examine each term, we need to break it up. It may, well, look, we can guess in this one because we don't have, remember, maths is not all about formulas alone. It's about guessing, intuition. You can explore, experiment, and get to some kind of way to determine the missing numbers. Well, this is a difficult one, but what we can look at is perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9. Therefore, each number is n squared plus 1. Now, you were taught quadratic sequences. So we'll be starting this session with quadratic sequence. The next one is more difficult. Student, I urge you to have pen and paper. Please write and try to follow, do calculation, so you can concentrate on the example, the question that we are working with. 3, 10, 29. I think that's getting a bit more difficult. So I will also encourage you to formulate your own sequence. Well, to follow up from the previous example, I've chosen cubes, cubic numbers. 1 cubed, 2 cubed, 3 cubed. And so if you add 2 to each, so it will be n cubed plus 2. Okay, that's a brief introduction to number patterns and sequence. The example that you see is from the 2018 DOE paper. Now this is the answer. 2, 3, 10, 23. Can you find the fourth term? Please try to work this out. I'll give you a minute or two and tell me how you arrived at your answer.
Hello, Shan. You are muted right now.
You know, I've got a question on the desktop. How do I get back there?
Sorry, Shan?
Give me a second.
Oh, sure.
The question paper is on the desktop.
Which one?
Sonia? Top one? Right. Yeah, okay. Okay, sorry about that. We're back. Um, are you with me now? Given the sequence 2, 3, 10, 23, write down the next term of the sequence. Well, that's 1 mark, but it's important to understand, to show how you arrive at your answer. Okay, the number, the first term is 2, followed by 3, 10, 23. Now, what is important, it's given as a quadratic sequence. That's important, right? And when you're working, just underline things like quadratic, arithmetic, geometric, so you can follow the required rules. Now, for a quadratic sequence, you have to do 2 things at the beginning. First, subtract, find the difference. 3 minus 2 is 1, 10 minus 3 is 7, 23 minus 10 is 13. And then you subtract again to find the second difference. And there you'll find that the difference is 6. So, let's get back to that question. No. Yeah, there we are. So you got 2, 3, 10, 23. You find the difference. That is 1, 7, 10, 13. Then the next row you find the difference again, which is 7 minus 1, 6. 13 minus 7 is 6. Therefore, the next number should be 19 to give you 6. But since you have 6 and 6, when that is a constant, so we are now dealing with a quadratic sequence, not arithmetic, not geometric. So here you have to do it twice. So to get 6, 13 plus 6 is 19. And how do you get to the next term? So this, write the numbers one below the other. 2 plus 1 is 3. 3 plus 7 is 10. 10 and 13 is 23. So the next term is 42. Okay, that's 1 mark. Well, if you guess the answer, good luck. Next, determine the nth term of the sequence. Remember, we are dealing with a quadratic sequence. So if it's quadratic, then think of the quadratic equation or quadratic expression, ax squared plus bx plus c. So for the quadratic sequence, we use Tn equal to an squared plus bn plus c. Now we want to find the general term. Please go through this carefully and practice as many times as possible because it's a very useful exercise. Tn equal to an squared plus bn plus c. When you substitute 1, which is the first term, so n squared is 1 squared. So you have A times 1 squared plus B times 1 plus C. So your first term is of the form A plus B plus C. The second term, you substitute n equal to 2. You get 2 squared, which is 4A plus 2B plus C. And similarly, you will get T3, the third term, by substituting n equal to 3. You get 9A plus 3B plus C. Now, if you look at the given sequence, T1 is 2, T3, T1 is 2, T2 is 3, T3 is 10. So you have 3 equations in 3 unknowns. Now you go to solve for A, B, and C. This is a very useful exercise. Please do a few examples and practice. Now you notice C appears 3 times. If you subtract, I'm going to number them equation 1, equation 2, equation 3. If you subtract the first from the second, or just say equation 2 minus equation 1, 3 minus 2 is 1, C minus C is 0, 2B minus B is B, 4A minus A is 3A. And if you subtract equation 3 minus equation 2, you will get 5A plus B equal to 7. So now you have 2 equations in 2 unknowns, that is A and B, because we have eliminated C. Now if you subtract 7 minus 1 is 6, B minus B 0, 5 minus 3 is 2. So you get 2A equal to 6, therefore A is equal to 3. Substitute A equal to 3 in this equation here. 3 times 3 is 9, plus B equal to 1, therefore B is equal to minus 8. And substitute A and B in equation 1, you will get C equal to 7. Please practice this, and it's very useful. And you need to do it accurately, because if you make one mistake, then you will lose quite a bit of marks. So if A is 3, B is minus 8, C is 7, therefore the general term is 3n squared minus 8n plus 7. So that's a general term. So let's go back to the question. Yeah. Okay, let's look at all the questions again. We've got, well, calculate the 20th term. It's simple. You substitute 20 in the equation, the general term, that's 3n squared minus 8n plus 7, you get an answer. And you can use a calculator to do that. Question 2.2. Notice this is an arithmetic sequence. So the first one is quadratic. The second one deals with the arithmetic sequence. Now you got 35, 28, 21. What do you think is the next number? You got 35, 28, 21. So the next number should be 14. But be very careful here. It's 35 minus 7 is 28. 28 minus 7 is 21. 21 minus 7 is 14. So the rule is you subtract 7 each time to get the next number. So that's a rule. Now, when you go on, so you got 35, 28, 21, 14, you get 7, then you get 0, then you get minus 7, minus 14. And if you go on, you should reach minus 140. But let's see how we can get there. Okay, so next. That should be quite easy to work out. It's one of these pages not in order. Yeah, okay, we are there on the top. 35, 28, 21. Now, the nth term of an arithmetic sequence is a plus n minus 1d. So you're given the nth term is minus 140. So you write the equation. The first term a is 35, and we established that the common difference is minus 7. Just substitute and you solve for n. Now you notice the numbers 35, 7, and 140. Minus 7 is common. So you divide all three by minus 7. 35 divided by minus 7 is minus 5. Minus 7 divided by minus 7 is 1, which is n minus 1. Minus 140 divided by minus 7 will give you 20. Now it's simple. Transpose, you got n minus 1 is 20, so n is equal to 20 plus 1. 20 plus 1 plus 5, which is 26. Right. So students, you observe that there are questions that are easy. You must work them out and get them right. Okay. We go on to the next question, which is a little more demanding, a little more complicated. For which value of n will the sum of the first n terms of the arithmetic sequence, question 2.2, will equal to the nth term of the quadratic sequence? So here we are dealing with two sequences, combining them. The sum of the first n terms of the arithmetic sequence must equal to the nth term of the quadratic. So this is important. The nth term of the quadratic sequence and the sum of the first n terms of the arithmetic sequence. So you're going to take the two and set up an equation. Now, what is the nth term of the quadratic? We already worked it out. Now you got the sum of the first n terms of the arithmetic. Okay, let's have a look. Why am I getting so long? Right. The nth term, which we already calculated, the nth term of the quadratic was 3n squared minus 8n plus 7. The sum of the nth term of the arithmetic sequence is n over 2 into a plus l, or you can use n over 2 into 2a plus n minus 1d. Learners, my advice to you is to write down, make your own list of formulas, sequence of series, trigonometry, whatever. Keep it, go through it, and make sure you apply the correct formula. You need to distinguish between the nth term and sum of n terms and their respective formulas. Okay, so you got this formula here, you substitute and you work, and you'll end up with a quadratic equation. And when you solve that, you get n equal to 7 or n equal to 2/3. No, it's 2 over 13. This is supposed to be 13 here. Now, n is equal to 1, can either be 1, 2, 3, 4, etc., counting numbers. N cannot be 2 over 13, so n is 7. It's a good example for you to work through and practice. Okay, we now go on to the next question. Right, this question 3 deals with a geometric series. Now, what is the difference between a geometric series and sequence? If you say 1, 2, 3, 4, it is a sequence. But you say 1 plus 2 plus 3 plus 4, by adding, like the sigma notation, becomes a series. A geometric series has a constant ratio of half, and the sum to infinity is 6. So can you see straight away you got sum to infinity, and you must know the formula. The formula is a over 1 minus r.
Shan, we have lost you. We no longer can hear anything that you are saying. Okay, guys, please be patient. I think Shan is having some network difficulties, but I'm sure he will be back. Hello, Shan, are you back?
Yes.
Okay, thank you so much.
So while we're waiting for Shan, does anyone have any questions about what we've gone through so far that they'd like to ask while we have a moment?
Hey, Rachel, you're muted.
Thank you. Okay, so while we're waiting for Shan to reconnect, I've just come up with this sequence of 4 terms. Can anyone tell me what the next term is? So first of all, we're going to start off finding the first difference. Okay, so we can see between 10 and 11 it's +1. Okay, and then between so between term 2 and term 3, we minus 1. And then between term 3 and term 4, we minus 3. So it's not an arithmetic sequence because there's no common difference, no first common difference. So let's check the second common difference. Sorry, the second difference. So the difference between +1 and -1, how we get there is by minusing 2. And then how do we get from -1 to -3? That's also minusing 2. So has anyone got the next term, term 5? You can put your answer in the chat or you can unmute yourself. Okay. So then I will just do it. So our common difference is the second difference and it's -2. So to get our next first difference, we need to minus 2. So then we get -5. Okay, so you can see the difference here is -2. So now we're on the right track. And then now we need to take 7 minus 5. Then we get that term 5 is 2. Does anyone have any questions about that? Okay, Shan, are you ready to carry on?
I don't think Shan is here, Rachel. You can continue.
Okay, I'll continue. Okay, right, so does anyone know how we would find the general formula for this? Anyone? Okay, so we know for a geometric sequence, Cn is an squared plus bn plus c. Okay, so then how we get A is we take this sorry, there we go. So our general term, the formula is going to be Tn is equal to an squared plus bn plus c. Yeah, and how we get A is we take this common difference and divide it by 2. So minus 2 over 2 is equal to minus 1. Okay, and then now to get C, this is quite an easy one because if we just make n 0, then whatever the value of T0 is going to be equal to C. So T0, this means wherever we see an n, we're going to substitute 0. So we have A times 0 squared plus B times 0 plus C. Okay, and then I'm just going to carry on over here. So we can see A times 0 squared is 0. That just goes away. B times 0 is 0, so that goes away. So we can see T0 is equal to C. So now what we have to do is work backwards from here and find what T0 could be. So okay, so we don't know what that is. So we're going to work back and find the first difference from the second difference. Okay, so all we need to do is fill in the blanks. We know that the second difference is minus 2 because it's the same. And then we ask ourselves what minus 2 gives 1. So basically 1 plus 2 is 3. And if you're not sure about it, you can just work the opposite way. So we have 3 minus 2 is 1. So we know we've done the right thing. Then it's question mark plus 3 gives 10. So we know the question mark is 7. Okay, I hope that makes sense. If it doesn't, feel free to ask a question and I'll be happy to go through it again. Okay, I can try. Okay, so here we go. So now we know that T0 here, T0 is 7. So 7 equals C and C is equal to 7. This is the same thing, but sometimes it's nicer to see variable equals number like that because it just makes more sense in the brain, but it's the exact same thing. Okay, so now we're starting to get there in terms of our general formula. So we have minus 1 n squared plus bn plus c. And we can see from here, c is equal to 7. Okay, so just write that out again. Okay, so now what we can do is take one of these terms here to work out what b could be, right? And the reason we don't choose T0 is because that will just leave us with 7 is equal to 7. So we don't want to use this one. We want to use one of these. Generally, we'll use T1. So this one's to find B. And this one we use to find C. Okay, so we use T1 because it's nice to substitute 1. So T1 is equal to minus 1 squared plus B plus 7. And T1 is 10, it was given to us. So we can substitute that in. Okay, so 1 squared is just 1, and we have the negative sign, so minus 1, plus B plus 7. And basically, we're just going to take these to the other side to calculate what b is. So take the 1 over its 11 minus 7, b is equal to 4. Okay, so Tn is equal to, so it's a bit all over the place, but here's where we found a. This is the second difference divided by 2. So we have minus n squared plus, here's b. So plus 4n plus, here's where we found c, 7. So that is the general formula for this sequence here. Does anyone have any questions about that? Okay. Okay, so I'm just going to stop sharing quickly while I get up the next question, because I see Shan hasn't come back to us yet. Okay, so I'm just going to do the May-June paper for 2021. Okay, so if you're following along, it's May-June for 2021, and it's the Department of Basic Education. Okay, so since we have started with number patterns, let's continue with that, and we're going to do question 2. Okay, so question 2.1, consider the quadratic sequence 72, 100, 120, 132, and so on. Okay, so for 2.1.1, we need to determine Tn, so the nth term of the sequence. And this is quadratic, so we've just done an example of these. So I'm going to give you, okay, let's say 1 minute to find the common difference. And then you can put your answer in the chat or unmute yourself and give me the answer. Okay, so I'll just write out the general form, an squared plus bn plus c. Okay, so we're waiting to see what the common difference is.
We'll have to get 2. We can't put all 70 students in that.
Okay, so does anyone have the common difference? Okay, I'm going to start working it out, and if you get it at any point, feel free to just shout out Okay, so I'm just going to write this again. Let's label it this time, T1, T2, T3, T4. Okay, so this is the terms in the sequence. Now we're going to work out the first difference. Okay, so the difference between 72 and 100, we've plus 28, all right? Then the difference here, plus 20, and then the difference here is plus 12. So that's the first difference. And we can see it's not the same, it's not a common first difference. So that makes sense when we think about the question, which says determine the nth term of the quadratic sequence. So you can just convince yourself that it is in fact a quadratic sequence. Okay, so how do we get from 28 to 20? We minus 8. How do we get from 20 to 12? We minus 8 again. So here's the second difference. Okay. So now we found that the common difference is minus 8. So then our next step is to calculate the general term. So the nth term, I mean. Okay, so we're going to do it the exact same way as the previous example. We're going to find A first. And how we do that is saying the second difference divided by 2. Okay, then the next step is to find C. And we do that by subbing in T0 into this formula here. So here's step 1, step 2, and step 3 is to find B. So we're going to substitute T1. Let me just say it into Tn. Okay. So I'm going to start with step 1. We need to find A. So A is equal to the second difference, the common difference, which is minus 8. Minus 8 divided by 2 is equal to minus 4. So at this stage, we have Tn is equal to, we substitute in minus 4 for A. So minus 4n squared plus bn plus c. Okay, so that's a good start. And now we need to find c. But before we do that, we need to find term 0. So term 0. Okay, so we just work backwards for this one. So we know that the common difference is minus 8. What did we do to get 28 from by minusing 8? So it's 28 plus 8, that should give us 36. Right, and to just check if that's correct, 36 minus 8 is 28. Then what? So T0 plus 36 gave us 72. Okay, we work that out. That should be 36. So 36 plus 36 is 72. So now we have T0. So what you can do at this point is just say C is equal to 36 because you worked it out. Or just to convince yourself, you can substitute T0 into this equation here, the one where we have A already. So T0, when we put the 0 here, that means every time we see an N, we are going to replace it with 0. So minus 4n squared becomes minus 4 0 squared plus b times 0 plus c. We worked out that C0 is 36. That goes away because it's multiplied by 0. That goes away because it's multiplied by 0. So 36 is equal to C. So now we've done step 2. Now, last of all, we just need to find B. So we're going to rewrite our equation and we're going to substitute in our values for A and C. So minus 4n squared plus bn plus 36. Now we're going to substitute in T1. So T1, every time we see an N, we replace it with a 1. So it's minus 4 times 1, B times 1, plus 36. What is T1? That was given as 72. So 72 equal to minus 4 plus B plus 36. So if we take this across, it's 36 plus 4, which is 40. So B is equal to 40. Okay. Okay, so now we can write out our formula and just substitute in our values for A, B, and C just to write it out nicely so we can use it for the next question. So we have minus 4 is A, plus 40, which is B times N, plus 36. Okay. So if everyone is clear on that, we can go on to the next question. You can put your questions in the chat, or you can unmute yourself and ask, I don't mind. Okay, so two says a term in the quadratic sequence 72, 100, 120, 132, so the sequence we've been working with, is equal to the 12th term of the sequence of first differences. So we're working with the sequence of first differences. So I'm just going to write that out. It was 36, 20, not 36, that was 40, 0, we won't include that. 20, 12. Okay, so this is our sequence of first differences. Okay. So basically what the question is saying, a term in this sequence here is equal to the 12th term of this sequence. And we need to find the position of the term in the quadratic sequence. So that's quite a lot to absorb in one go. So let's just write out all the information we know. Okay, so this is our quadratic. And what we know is somewhere along here is our term. Let's call it x. Sorry. And we know that x is the 12th term of this first difference. So imagine this is a sequence of terms. So we have, this is T1, T2, T3, right? So we're just looking at the sequence of first differences as if it was its own sequence. Okay, and then it continues until T12, which we know is x. Then now we need to determine the position of this term in the quadratic. So let me just label it. This is a quadratic. This is the first difference. So basically what the question is asking is, where is this term? It's T what? Okay, so we just need to work with the information that we have. And that information is, so we're going to start with the first difference. Find Tn for the first differences. Then we need to find x. Okay, and then we're going to substitute x into Tn for the quadratic. Okay, so instead of Tn, let me call this Rn so we don't get confused. It's going to be just the same as finding Tn, but I'm just going to call it R instead of a T so it doesn't get confusing with multiple Tn's. So okay, so for just our arithmetic sequence, so one with a common first difference, like this one, -8, -8. So we're just looking at this as its own sequence. We're ignoring the quadratic sequence for now. So we have there's going to be a plus bn. So we need T0 of this sequence. So I had scratched it out here, but T0 is 36. So T0 is substituted in there, and then we'll just substitute in T1. So you can see that it is the common difference. So our sequence for this first difference is going to be 36 minus 8n. Okay, so now that we found the general sequence, what we're going to do is find the value of the 12th term. Okay, so we're going to substitute T12, or that would be R. Since we're calling this R, let's call it R everywhere. So we have R12 is equal to 36 minus 8 times 12. So that should be minus 60. Okay, so we found out that x is equal to minus 60. So this value is 60. Okay, so now we've done the first part. What we need to do next is find where 60 is in this quadratic term, in this quadratic sequence. So how we do that is we're going to substitute this value into this formula here. So okay, so we don't know what value of n the 60 sits at, right? So we can't substitute anything in here for n, or for n. But we do know that Tn, so T, we don't know what it is 60. So that's why, sorry, it is minus 60. Minus 60. So we're going to take Tn, and we're going to say minus 60 is equal to minus 4n squared plus 40, because we're substituting it into the quadratic equation now, plus 36. Okay, and then hopefully this looks familiar, like a factorizing problem. Minus 40n squared, sorry, minus 4n squared plus 40n plus 96. We can divide through by minus 4 just to make it easier. So we have n squared minus 10n minus 27. Okay, and then we just need to factorize this. So hopefully everyone knows how to do factorizing. I'm just going to show you my way, but if you understand your way, then keep doing that one. Okay, so if you want to learn my way, I'll just go through it quickly. We look at this term and divide it into two of its factors. So 12 times 2 will give us 24. And then you look at these factors here. So in this case, it would be 1 and 10 or 2 and 5. And then you put them here, 1, 2, 2, 1, etc. And then you would just, sorry. So you would take 1 here and divide that up. If you had a value for A, 1 and 1, you divide this up into its factors. So 1 times 24, 2 times 12, 3 times 8, etc. And you write them on this side. And you try and add or subtract these two values from each other to try get this middle term. So minus 12 plus 2 is going to give us 10. And then what you do is just multiply. So you just make this cross, and then this will be the coefficient for the 1, and this will be the other term. Okay, so to factorize this now, we have 0. So from this bit, 0 is equal to 1n plus 2 times 1n minus 4. N plus 2, n minus 12. So then we know that n could either be minus 2 or n could equal 12. Okay, and we can see we have a negative number here. We don't deal with negative term numbers, so you don't get like c of minus 2. We don't do that. So we can take away this solution. So we have that our final solution is n is equal to 12. So this is the position where that minus 60 sits in the quadratic sequence. Okay, so that was quite a long one. Does anyone have any questions about that? Anything at all? Let me just show the whole working. So did anyone get lost at any points in this working out? Okay, so I'm going to take that as a no. But if you do realize you have a question, then please feel free to put it in the chat and I'll be happy to go back and answer. Okay, I'm just going to quickly set up the next question. Shan, are you back? Would you like to continue? Okay, the next question is, find the maximum value of the quadratic equation. So we should be very familiar with this sequence by now, but I'll just write it out if you want. So we all have it in front of us. 100, 120. What is the maximum value of the quadratic? So as you remember, the common difference is minus 8. So what is the least we're going to have to say? First increasing.
Sorry.
Yes. So this is a quadratic. And if you remember from doing graphs and things?
Now, while the Zoom meeting is on, I want to open up another document. How do I do that?
Let's start with quadratic. You can imagine it being of the form y is equal to minus 4x squared
Yeah.
plus 40
Yeah.
plus 36. And from this negative, you can see that I'm happy quadratic like that. Okay? It's going to have a maximum value.
Rachel, sorry, your audio is not.
Yeah.
Can you please repeat that?
Okay. So since we're working with a quadratic
Disable share. Now the Zoom it's on my desktop. Now I'm gonna go to share screen.
Then would you like to take over?
Yeah, that's what I didn't do. Yeah.
I'm just going to power on so Shan take over. So we have Tn is equal to minus 4Tn.
We go to share screen. No, we go to PDF.
And we can say it looks very similar to what we'd work with in a quadratic graph, where you'd have y is equal to minus 4x squared plus 40x plus 36. And this kind of quadratic would look like a sad face. So it would look like that. And then if you look at this graph, that would be your x, that would be your y. Then you can see that there's some point where there's a maximum. So it increases up to the maximum, then decreases afterwards. And that same sort of thing is going to happen here. And the reason for that is because the common difference is negative. So originally it was increasing, but eventually the negatives are going to make this first difference negative. So eventually the sequence is going to decrease. So now we need to find where it is the largest. Okay, so there's different ways that we can do this. The first is we have Tn minus 4n plus 40n plus 36. Okay, and have you learned about derivatives yet? Okay, so this is one of the solutions. I don't know if you've okay, so if we take the derivative, right, we have minus 4n squared. We're going to take the minus 4 times it by 2. And then minus 1 from this exponent. So we have minus 8n. And then here we take the 1, multiply 40 by 1. So we get 40, and then minus 1 from this exponent here. So it's n to the 0, which is just 1. So we can let that disappear. Now, when we set this first derivative to 0, that's going to find the value at which this is a maximum or minimum. Okay, so let's just set it to 0. Okay, so 8n is equal to 40. So n is equal to 5. So this is the value where the quadratic is going to be the biggest. And how do we know that it's the biggest and not the smallest? Well, that's because here we can see that there is a biggest value, right? But there's technically no smallest value because it goes all the way down into infinity, negative infinity. Okay, so we can be assured that this is the biggest value. So all we have to do now is find T5. So minus 4, 5 squared, plus 40 times 5, plus 36. That's minus 100 plus 200 plus 36. So that will give us 136. Okay, and if you want to convince yourself, let's take a look here. We can see from T1, we're increasing. So 72 to 100 to 120, 132, 136. If we have T6, that's going to be minus 4 times 6 squared plus 40 times 6 plus 36. So that's minus 4 times 36 plus 40 times 6 plus 36. So that's going to give us 144. Sorry, minus 144 plus 240 plus 36. Which I think gives 132. You can correct me if I'm wrong. Okay, so as you can see, we increase all the way up to T5, and then it starts to decrease. So now we've just convinced ourselves that the answer we found is actually correct. So Shan, I see that you're back. Would you like to take over? Okay. So does anyone have any questions about this question we just finished? Has anyone done it a different way that they'd like to share to see if it's correct? Okay. So now let's do 2.2. We have a sequence, minus 11 to sine of 3x, 15. Okay, so the question says, determine the values of x in the interval from 0 degrees to 90 degrees, for which the sequence will be arithmetic. So x needs to be within 0 degrees and 90 degrees. And we need the sequence to be arithmetic. Okay, so this is hopefully going to give us some idea of what this value needs to be. Okay, so the way I would do it is we take the difference between term 1 and term 3 divided by 2, and that should be the difference between term 1, term 2, and term 2 and term 3. Okay, so term 3 minus term 1 is going to be 15 plus 11 to give us 26. Okay, so that's the difference between term 1 and term 3, but we want the difference between term 1 and 2 and 3. But luckily we have an arithmetic sequence. So that means that this difference here and this difference here is going to be the same. And because it's the same, that means we can divide this by 2. So if I just write this out again, minus 11 to find 3x and 15. This difference is going to be 13. And this difference is going to be 13. That is 26 divided by 2. Okay, so we look at that. That would mean that term 2 is equal to minus 11 plus 13. So that's 2. So that means term 2 is equal to 2. But term 2 is also equal to 2 sine 3x. So that means we divide through by 2. 1 is equal to sine 3x. Okay, so now we just need to solve for this. When is sine of something equal to 1? Well, if you're not sure, we can draw this. That's our sine graph. That's 1, that's minus 1. That's 180, 90, 0. And we don't really need these values, but I just put them in anyway. Okay, so where's it equal to 1? Well, when this value here is equal, when this value here is equal to 90, then this whole thing is equal to 1. So what we can do is say 3x is equal to 90 degrees. And then it's just simply taking the 3 over to the other side, so dividing by 3, and we get x is equal to 30. So when x is equal to 30, that means that this value is 2, which means that this entire sequence here is arithmetic sequence. So that's one of your problem-solving questions. It's not exactly difficult, but it just takes like a bit of outside the box thinking. Does anyone have any questions?
Sorry.
Yes.
Can we check, please, what will the value of T2 just to confirm
Okay.
the exact value of T2?
Oh, yes.
How can we find that? Yeah.
Okay. So we know that we need this to be an arithmetic sequence. So
Yeah.
that means, say this is X, right?
Mm.
This is the first difference, and it's going to be the same because it's arithmetic. So what we're going to do is find the difference between the two values we do know. So how did we get from -11 to 15? Right?
Yes.
We added 26. So we work that out. T3 minus T1. So 15 minus 11. So we add 11, we get 26. So 26 is the difference between T3 and T1. So it's equal to X plus X. The common difference.
Yeah.
So 23 is equal to 2X. That means X is equal to 13. So we called the first common difference X. So that means this difference here is 13. So I've rewritten it here. Here's the first difference.
Okay.
Okay. So then to get from T1 to T2, we're just going to take T1, add the common difference. So minus 11 plus 13 is equal to 2.
2.
There we go. So we know that that is 2, and it is also 2 sound 3.
Okay.
That help?
Yeah, sure. Thanks.
Perfect. Okay, I think we have time for one more question. So I missed out 2.1.4. So let's just hop back one question to that one. It says determine the maximum value of the sequence. So now we have a different sequence. -3, 5, 25, 37. Okay, so this question is only out of 1. So we probably don't have to find Tn and work out all of those things, because if you see 2.1.1, that question was out of 4. So that probably means that there's an easy way or a quick way to find what the maximum value is. So this difference here is 28, 20, 12, -8, -8. Okay, so now if you look at this value is 12. So it's not that much bigger than 8. So when we take away 8 from it twice, it's going to be a negative number. So we know pretty soon this value is going to reach its peak and then start decreasing. So 12 minus 8, we get 4. So add 4 to 36, to 37, we get 41. And now to get the next first difference, we can take 4 minus 8, we get -4. So 41 minus 4 is 37. And now we can see that it has increased all the way up to 41. And now it is going to decrease because we are minusing 8 from a negative number. So for the next, it's going to be minus 12. So it's going to get even smaller. Then it's going to be minus 20, minus 28, so on. So that's the biggest value we get. So that's just 41. So all you need to do is find the common difference, add the first common difference, add it again to make sure that the next value is smaller. Okay. Any final questions before we finish? Okay, so we've completely finished question 2 of the 2021 May-June paper 1. So I hope this helps in terms of working out sequences. So that's all we have for today. I think there's just a couple of announcements before everyone leaves.
Thank you so much, Rachel, and thank you so much to everyone who attended today. In the chat, I have put up a link there. We would truly appreciate it as the University of KwaZulu-Natal if you could kindly just fill in that survey. It will take you literally 2 minutes to fill in that survey. And just before everyone leaves, can we please play this video provided to us by the University of KwaZulu-Natal. Can you hear the sound? Can you hear the sound?
Yes, yes, we can.
Thank you so much.
Part of the UKZN experience is the opportunity to be part of a community and to network with not only our world-renowned academics, but with future game changers and leaders. They do say that the extent of one's success can be attributed to those they rub shoulders with. Therefore, you must surround yourself with like-minded people. So, how do you become part of a community that is committed to your self-development? How do you become part of UKZN? First, you have to apply. All applications for undergraduate studies at UKZN are processed through the Central Applications Office, CAO. This is for both your course and student residence application. The application process is as follows. Step 1. Consult the CAO handbook. This handbook provides a list of all qualifications available at UKZN. Step 2. Have a look through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom in accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westport. Then BCN stands for the actual course. Make sure to get these codes right. Step 4. Use this program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. You can always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za. It's that easy. Pay close attention to closing dates for qualifications. For example, MBCHB closes on the 30th of June, while other undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
Thank you so much. We will also have another session today at 2 o'clock today, but everything is in your poster that you have received about these programs. Thank you so much. Please don't forget to fill in the survey. We will see you all later today. Thank you. Bye.
Hi.